Hey guys, today we continue our lesson on scatter plots and finding the line of best fit, analyzing it with the y equals mx plus b equation from the last couple of days. The goal for the lesson today, however, is to use technology to find the equation of the line of best fit. We learned how to do it visually and how to come up with the equation just drawing the line, but today we are going to try to be a little bit more exact, and we'll use technology. So just for a quick review, scatter plots give us the relationship between two variables, dependent and independent variable. The line of best fit, we said, is the trend line, and it also represents gives us a description of that relationship between the two variables. We also discussed the correlation coefficient R, and we learned that when R is -1, we have a strong negative correlation. When R is +1, we have a strong positive correlation, and when R is 0, there's no correlation between the variables. Okay, so let's focus here on question number 1. Look what they're asking us. Which of the following graphs best shows a strong negative association between the variables d and t? So they ask us to find the scatter plot that is best described by a strong negative correlation between the two variables. And just looking at them, you know that fourth option is the one we're looking for. So if you picture the line of best fit, this is the line with negative slope and a strong negative close to -1, right? That's what determines a strong negative association. So for a quick review from yesterday, what did we learn? How did we learn to find the line of best fit? Well, we'll look at our scatter plot as question number 2 asks us to do. Draw the line of best fit, and then we'll find them, write the equation of the line of best fit. Our equation always has to be mx plus b. I'm using the about sign because we know it's approximate, right? So looking at that scatter plot, I can do that would be a line of best fit, and we know that this is going to be +5 is our y-intercept, and I would say approximately -3/4x plus b. But this is about, right? So here comes the question, how can we be more accurate in our equation? How can we be more precise with our calculations and finding the line of best fit and describing it with an equation? Well, that's where we are going to use our online graphing calculator, Desmos. We've used it many times before, but today we'll see how it really helps us with the lines of best fit. So the tabular format here of the data set it's pretty much the same data set, a little bit more points than the ones in the previous graph, but I am going to take these values and I'm going to use Desmos to find the equation of the line of best fit, and actually Desmos is going to plot it for me as well. So remember, when we are given a table of values and we have domain and range, domain is going to be our independent variable and range is going to be our dependent variable. So I'm going to call the domain x sub 1 and the range y sub 1. These are the variables I'm going to use for the Desmos calculator. So I'm going to come to Desmos. I'm going to click on that plus sign over here. From the drop down of options, I will select table because that's what I want to enter. And you see x sub 1, y sub 1 are the default options. That's why I decided to use them. And I will transfer the values. So -417, -27. I'll have -4, 17, -2, 7. Then I have 0, 8, 1, 3. Then I'm going to 0, 8, 1, 3. And then I have 2, 1, 3, 2, 2, 1, 3, 2, 4, 5, 6, -2, 4. And notice that it's automatically plotting the points for me, so it's really handy and quick. 8, 2, 8, -5. And the last two are 8, 2, 8, and -5. This is my whole scatter plot. So I am going to now find and graph the line of best fit. So I'm going to come to the second row here in that section. I will write y sub 1 about mx sub 1 plus, oopsie, plus b. And you see that my calculations are already done for me, and the line of best fit is graphed by Desmos. So from here, I see the slope is -1.26913, the y-intercept is 7.09973, and the coefficient of correlation is -0.8459. With that information, I have the equation of the line of best fit. I have the line of best fit. It's automatically graphed for me. And now I can make predictions for exact values for certain values of y and x. And that is how we use technology to find the line of best fit, to find the correlation coefficient with more precision and more accuracy.